Welcome to the last in the series on the Forum in Law, Ethics, and Society here at Sonoma State University. We've gone through an entire fall semester weathering plagues, fires, other disasters, and we've gotten through the whole thing. So give yourself a hand in making it this far. It's a bit of an achievement this semester. So we've had some great talks, and today I'm going to wrap up the session with an introduction to a book that I co-authored that will be coming out in January. Just a couple of things while we are getting started here. Remember that please put your questions in the Q&A tab that you'll find down at the bottom of your screen, and there's a question and answer, a poll tab down there as well. I'll be having 2 or 3 polls that we'll be doing during the course of the talk as well. In fact, I might as well, while we're waiting for people to come in, let's do the first one. And so this one is a question: are computers intelligent? So let's launch that while people are still taking their seats, and we'll see what the results of that are here in a moment. Okay, let me start sharing my screen, and we will see where we can go with this particular lecture. All right, screen is now shared, and let's go to the correct program. There it is. All right, and we are ready to roll now. Okay, so let's talk a little bit about this book. So this book's coming out, like I said, January 14th. 1 or 2 of the authors is here with us today as well, other authors. This book was the brainchild of Eric Dietrich, who was my advisor in my PhD program in Binghamton University in New York. The great Chris Fields, from Van Hoevelen, Robin Zabrowski, all great people who have been working on these problems for multiple decades. So originally our plan was to produce a reader on artificial intelligence, but for various legal reasons, those are hard to produce anymore. So we put our heads together, and over 2 or 3 years, we produced a new book that critically evaluates all of the important readings in artificial intelligence. So it talks about AI and philosophy, what we call the AI wars, kind of a history of where the debates went. And then in the last part of the book, we go beyond the historical concerns about AI and look at what's relevant for today. All of this is great stuff. I'm going to try to summarize 300 plus pages in just a less than an hour, so wish me luck. Like I said, extensive, and this is basically my elevator speech. This is an extensive look at the important debates that shaped the turn from symbolic to sub-symbolic AI and the prospects for artificial general intelligence, with proper attention being paid to the ethical implications of all forms of AI. All right, let's take a look at our first problem here. So this is one of the main motivations of the book. In 1978, philosopher, AI researcher, Aaron Sullins wrote this quote, a very important quote. I'll read the whole thing. "I'm prepared to go so far as to say that within a few years, if there remain any philosophers who are not familiar with some of the main developments in artificial intelligence, it will be fair to accuse them of professional incompetence, and that to teach courses in philosophy of mind, epistemology, aesthetics, philosophy of science, philosophy of language, ethics, metaphysics, and other main areas of philosophy without discussing the relevant aspects of artificial intelligence will be as irresponsible as giving a degree course in physics, which includes no quantum theory." So this is a strong statement. The philosophy, basically, in 1978, according to Sloman, was to have made this turn towards AI as a fundamental aspect of what we do in philosophy. Well, 40 years later, this doesn't seem to be the case. No philosophy departments, or very few anyway, have taken this on seriously. And most philosophers don't really know much about AI except what you might read in the news. They certainly don't study it, and they certainly don't bring it into all of their classes. Even here at Sonoma State, I think I'm pretty much the only teacher in the philosophy department here that takes AI seriously. So I listened to Aaron, um, but few other people did, and maybe I'm the one that made the mistake, right? So uh, there are, of course, right, early overzealous enthusiasm for this new discovery of AI and unproven technology. Um, but why did this fizzle, right? Why did this fizzle as much as it did? While AI often makes the news, it is not because AI has reached human level intelligence. Nothing like human level AI exists. You've probably all got an Amazon Echo or a Siri or a Google Dot or something in your home, a smart speaker. It's not like HAL in the movie 2001. It's interesting. It has some interesting capabilities. We want them and we put them in our houses, but it's not because they're like another person in the room. So AI did not achieve that level. Uh, so we're going to take a look at why this first wave of AI fizzled, because really when it was advanced as a topic of study, it was to create machine brains that were equivalent or surpassed human intelligence. So what happened there? Our argument's going to be that actually the philosophical arguments against this style of AI were strong, but they they were fought basically to a draw. Okay, so that's what we're going to look at next. Let's look at the AI wars. So the AI wars took place 1950 to 2000. These issues that we're going to be talking about here and introducing are still debated to some extent, but neither the pro nor the con, the anti-AI arguments have changed significantly. Pretty much the same sort of people hold the positions that they held for 40 or more years. Both sides today have kind of claimed victory, which is we take as evidence that neither side really is victorious. The cons will claim, look, we don't see human level artificial general intelligence. It doesn't exist. The technology isn't out there. The pro side will say, yeah, but look, AI is actually everywhere, and that's true, right? It's all over your phones. It's all over any computer technology that you're currently using. There's some aspect of AI or AI machine learning that's part of this story. Okay, so the AI wars were fought from 1950 to 2000. These, of course, are theoretical wars, not actual wars. The actual AI wars began in the 90s, and we'll talk about that later with killer robots and drones and that sort of thing. So there we see an early computer, the IBM 702. This was a machine that many early AI researchers were using, and it's got the spinning magnetic tape and the blinking lights and all the stuff that you expect out of a gigantic computer. Way less powerful than the one that you currently have in your pocket, but nonetheless, those folks in their fancy suits believed that they would be able to take that kind of a machine and build it into a brain that was equivalent to the one that you have in your skull. So let's take a look now at our first poll and see what we have. So are computers intelligent? The poll that we've taken says clear winner of yes. So 81% yes, 19% no. So the one of the early thinkers within this field, Alan Turing, uh, once made this claim that by the year 2000, anyone, if you just said our computer's intelligence, you could advance that claim without expecting to be contradicted. And it looks like, at least with this crowd today, this afternoon, that's mostly true. So entire careers were spent fighting various battles in these wars until both sides fought to a draw. First one is the logic war. So in this one, uh, this particular set of philosophical battles was: are there logical limitations to computers which could prevent AI completely? So is there a problem with logic itself, since the computer is just a logic machine, that would prevent logic from building a system that was equivalent to what's going on in your own brain? So of course, Alan Turing, the man who thought that that these machines would be ubiquitous by the year 2000, uh, came up with one of the most famous tests, which basically is, you can imagine it today. He explained it a little bit differently in the 50s, but you can imagine it today. Can you be texting with a computer and then your friend? So let's say you're texting with two people you think are two people. Unbeknownst to you, one is a computer and the other is an actual human being. Can the computer get to the point where it can totally fool you? So let's say maybe you're texting tech support, and you're talking to who you think is a technician somewhere on the planet, but it's actually just a machine, and the machine is giving you everything you need to know about fulfilling its role as a conversation partner. So that was the Turing test, and Turing thought that as soon as computers could pass that kind of a test, then we could just say they're intelligent. They would be functionally equivalent to an intelligence of our level. Of course, the mathematician Kurt Gödel has produced a kind of really interesting and complex proof that suggests there are certain limits to what logic can do. Church and Turing, two other logicians, also produced theorems that sort of point to where the boundaries are in what counts as computation, what doesn't count as computation. So the argument then, so we have sort of a notion of the boundaries of where math and logic stop. But the question still remains: is consciousness and human intelligence inside that boundary, or does it permeate that boundary in some way? So we have in our second chapter, we go into great depth in this. How would we know if a computer was intelligent? I was reading an article recently that suggests that that this guy was seriously entertaining the thought that the internet was intelligent because it has enough nodes and connections on it that it's starting to get close to or surpass the human brain. So how would you know that the internet became a conscious entity unto itself? And it was suggesting a couple of different answers. Basically, the main answer was that we would become nodes in this machine, and so our personality would start conforming to the machine's personality. Interesting idea, but really, it's all theoretical, and we're still just talking about it at this particular point. Okay, the next war was the architecture war, which was a war over which particular architectures do these machines, is serial architecture in computers too limiting? Do we have to move to a parallel processing kind of architecture? Those sorts of questions are asked in this particular chapter. So in this one, we look at the really interesting story about how behaviorism and philosophers and psychologists around the middle of the last century were arguing that maybe it's the case that we don't even really have minds. and that really is all that matters is behavior. We don't really have to talk about the mind and the brain. Well, we could talk about the brain, but we don't have to talk about the mind itself. Interestingly enough, um, it was computer science that brought the mind back to as something that psychologists could talk about. So this would be the cognitive revolution, and as we moved into as cognitive science thoroughly and completely refutes behaviorism, and concurrently the logical positivists are thoroughly and completely defeated as well. And this opens up the world again to allow philosophy to start talking about things that it had been embarrassed about in the past. So it starts allowing us to talk about things like consciousness and the mind without getting thrown out of the room. And this is thanks to computer scientists. So we go through this argument in this chapter. Um, Computer science is not the science of computer behavior. It's the stuff that's happening. Computer scientists are interested in what's going on inside the machine itself. The machine itself won't work unless we know what's going on inside the machine. And then there is this concept of the virtual machine. So I've got this little diagram here so you can see how computers break up. Even what we're doing right now, right? It's running on off of some server somewhere that's running on your particular computer. It could be a laptop, it could be a Chromebook, it could be a phone, it could be an iPad, right? Any sort of there's a myriad cases of what physical computer you're looking at. And then you're looking at a virtual machine, the Zoom, in this instance, virtual machine, and it's behaving the way it behaves. And but it's interesting, you know, you ask the question like, where is Zoom? Um, it doesn't really exist. I mean, it can't exist without these lower levels, but it doesn't really completely exist only on those lower levels. It exists here, right here in cyberspace where we're at. So virtual machines gave us a way of thinking about the mind. Maybe the mind just isn't just the behavior that's coming out of my body. It isn't just my body. It isn't just my brain, but it's a thing that sits on top of it the way a program sits on top of the physical apparatus that exists in a computer. Okay, so that was a brilliant argument and allowed philosophers to um, uh, enter new territory, right? We didn't have to just stick with physics and the physical manifestations. These become kind of unimportant. They could be anything. Like I said, it doesn't matter what kind of machine you're listening to me on. What matters is that you're getting the experience. Freed from this need to reduce everything to particular physical implementations was the leap that AI was looking for, and made the concept of artificial intelligence essentially inevitable. The argument being that this finally, we've got an example of what the mind actually is. It's a computer, right? Specifically, types of virtual machines run on top of biological computing machinery in your skull. Okay, so that was the second war. The third war, the consciousness wars, the wars over whether computers could ever think about anything at all. So think about this, like uh, a mousetrap is in a sense, it's a kind of computer. It has inputs, it has outputs, it has stored potential energy, and you input some cheese, and you input a mouse, and you output a dead mouse. So it's a simple little machine, but it has computational aspects to it. Uh, Here's the question: does the mousetrap know it caught the mouse? Does it care whether it caught the mouse? Right? It seems ridiculous to suggest that it does. So um, this should bring us, I think, to our second poll. Let's do our next poll. If I can get this to work. Okay. Here we go. I'm learning how to use Zoom. All right, here is the second question. So you all own a Siri, or at least you have Siri in your phone, or you might have some other, Cortana or some other similar agent on your phone, computational agent. So I want to ask this question: is Siri aware of who you are? So I'll launch that poll, and we'll let those results go for a little while we talk about this. Okay, so are mousetraps anything? Do they know what they're doing? So this is where we get into a pretty complex piece of philosophical argumentation that has gone for many decades, people arguing back and forth on this. But the concept's a little easy to understand. The implications are what's harder to understand. So the philosopher John Searle at Berkeley came up with this idea, and if you look at the picture right over there on the right, you can zoom in on it. You can't read it, so that's sorry for my crappy illustration there. But basically, what we're trying to understand with that picture is you've got a guy inside a room, right? He's got a big instruction book in front of him, and he has various slots that he can get papers passed into the room, and he can pass papers back out of the room. So what's going on the outside are some Chinese natural language speakers, and they are asking questions in Chinese. Maybe they're asking about a Chinese fable or something, and so they put the question in to the box in Chinese. So then our person inside the room looks at these instructions inside the book and tries to match these symbols. So this works if you don't speak Chinese. This argument is harder to understand if you do, but just insert some other language that you don't understand. So you've got some language you don't understand, and it doesn't even use the same sort of letters that you use in the language that you understand, but it does give you instructions on how to translate those letters into other letters of that same language, right? So if you see these shapes followed by these shapes, then produce these shapes followed by these shapes, and then you output that, right? So to people looking outside the box, the natural Chinese language speakers, they would be putting questions in Chinese, and they'd be getting answers out in Chinese that made sense, right? That makes sense. You ask the box a question, the question thinks about it for a couple seconds, out comes an answer that you can actually understand, and that does make sense. So this, I think, is a great example of what, this could be what's happening inside Siri. So if this is what's happening inside Siri, then we have this question: does this person inside the box, understand the Chinese language? Now, he can produce behavior as if he does understand the Chinese language, but the question is, has he learned any Chinese? When you look at is this how you would learn Chinese with these types of instructions? Okay. So this is an argument that bounces back and forth over multiple decades, and as you can see, we go through 6 different counter arguments against this particular style of argumentation. The quick answer for today is there really isn't a good answer, but some of us in the authors of the book are very dismissive of the Chinese room argument. A couple of us see some value in it, and I think that's true across the board. So it's sort of roughly mixed. Let's see what the results of our poll were. Okay. Kind of all over the board, but mostly the winner with 41% is no, but the owners of Siri know facts about me that they use. That's my answer too. So I'm with the 41% here. Only 16% think that Siri actually knows who you are. Like Siri's like you're listening to this talk, right? You're not talking to Siri right now, but Siri is thinking, I wonder what Joe's doing right now. I wish Joe would talk to me, right? Is that going on? Is that going on in Siri's head or not? 10% of you think that Siri has no concept of who you are. It's just, and then the yes, but Siri only knows certain facts about me is 33%. So we're still, you can see as a culture, we're still kind of all over the board on this particular idea. Okay, then there is the last of the 4 wars that were fought between 50 and 2000. This is the creativity war, whether or not computers can be creative and figure out the subtle relevancy of connections that knit our world together, right? All the various connections that we use to construct a concept. Like if I asked all of you to write a little essay right now about where you are, you would be able to do so. You'd be able to say, I'm in a room, I'm sitting on my bed, I've got my Chromebook open, I'm in my childhood room because of COVID that has made me have to live with my parents, even though I would rather be at college partying with my friends, right? You'd be able to construct a whole little story like that, right? Now, the question is, can machines construct things like that? Can Siri, like, would Siri be able to write that essay? You know, I'm sitting here on top of a desk in my owner's living room, and I'm thinking about various thoughts. I'm worried about COVID, right? Would it be able to write an essay like that? So the frame problem is the problem that a machine has to solve in order to do that. You take all the myriad information that's pouring into you right now, and you cut it into manageable frames. And those frames can be aspects of a story, a self narrative that you write about yourself. All humans can do this. Maybe some animals can do this. Can computers do this? So here's a little bit more detail on what the frame problem is. It's complex, right? We'd have to spend a week or so on this to get a complete understanding of it. But it's notoriously a big problem for computers for them to for a computer who is an artificial general intelligence has to be able to move from frame to frame to frame. It has to know the difference, how you behave differently in a church or in a restaurant or on the highway or in a war zone or at the UN, right? Whenever the frame changes, you have to change your behavior, and the computer would have to change its behavior as well. What we have done is we've just taken these machines and narrowed the frame in which they operate, right? So in order to make this less and less of a problem, we make our machines less and less general. We make them more and more specific, and that helps solve the frame problem. But this main question still exists for a machine, a general intelligent machine, a machine like the robots we see in movies, right, that move from situation to situation, that are actual characters, that advance storylines, right? Those kind of machines would have to solve this frame problem. Okay, so those were the main wars there. Still have a little bit of time left, looks like. So that's good news. Let's get into the second part of the book, Beyond the AI Wars. So our argument is that those wars happened, they're important, they were never resolved. Basically, what happened was the industry punted on all of those questions and decided it didn't need to answer them. So those are the great philosophical objections to AI. They're still open, but the industry has kind of turned its back on that and not cared about the answers to those questions anymore, and has moved on. So, so they are no longer of primary interest for the world of AI. They may still be of some interest to philosophers. But now we've moved into questions about AI consciousness and ethics that have clearly taken center stage. So we're going to consider those issues. Um, so in chapter 7, we talk a little bit about what consciousness is, and the argument: are machines conscious? Are machines could they be conscious? Is the internet conscious? Right. Chapter 8, we talk about ethical issues surrounding AI applications. Remember, AI applications are what you do to ignore the frame problem, is you just narrow your application down to a very specific thing. And then when we do that, it turns out that AI can be wildly successful. But because because the machine narrows the frame so far, it has no capacity to understand the impacts that it's causing ethically around it. Zero chance that it can understand that. And so that causes problems, which cause people to hit the streets, um, which causes you to worry about whether or not Siri is secretly a spy for Apple in your house, and that they're using that information against you to sell you various products you don't need, for instance. And then in chapter 9, we talk about embodied AI as potentially a way to solve all these problems, right? This is the where philosophers have started to come up with the argument that maybe one of the problems why AI can't solve some of these general AI problems is because the way we build them is completely wrong. We've forgotten that a huge part of why we are the kind of creatures we are has to do with the fact that we have a body that moves around in a world and has to survive in that world. And that has allowed us to evolve a general intelligence that we see in animals and even a little bit in plants, but we don't necessarily see very well in our machines yet. But we could if we make some changes. All right, so let's talk about the consciousness problem. Are machines aware? Um, um, uh, this is one of the things that we cherish as humans, right? You are aware that you are a human, a particular human with a particular name and a particular history in a particular place and a particular time. And that's one of the things that makes your life worth living, right? So what are the things that are conscious in the world? This is the thing that we care about the most. Your consciousness matters. Like when you, if you something was to happen to your brain and you were not to die, but you were to enter a vegetative state of which there was no chance of you coming out of, that would be something that your family would worry about, right? That would be a tragedy. So we don't just care for life; we care for conscious life, right? So the very core of what it means to be human. And we talk about this in chapter 5. Now, we're going to look at the neuroscience challenge to all this. So we've had philosophers in the mix so far. We've had logicians in the mix. We've had computer scientists in the mix. But at this point, the actual field of medicine and biology enters the mix. So it's an important question that neuroscientists have to answer when they're working on your brain like this. It matters whether or not you're aware of what's happening. If somebody's slicing into your body, you don't want to be aware. We want to be able to control consciousness. I'm unconscious during the surgery. I definitely want to be conscious after the surgery. So this is a question that doctors have to answer all the time. When somebody enters a vegetative state, have they lost consciousness, or have they just lost the ability to convince us that they're conscious? If we were to turn off the machine on a conscious entity, we would consider that murder, right? Are fetuses conscious, right? Do they have a meaningful consciousness? That changes what you believe about abortion, whether what your answer is on that question. So this is important, very important work, and this has created this new debate on awareness, the new focus on. We've had to allow a whole new level of science into these arguments. Okay, so this brings up a problem of interdisciplinarity. We have some cool machines now that we can do some scans and we look at the data and we can see what's going on in a brain in somebody that we think is in a vegetative state or minimally conscious state or a fully conscious state. We get different readings. And so we use that data to determine which people we're going to pull the plug on and which people we're going to let try to heal. So we need philosophers to help answer these kind of tough ethical and metaphysical questions. So philosophers, of course, well versed in logic. We take a lot of classes in logic. We have some background in computer science. At least a few of us do. But very few of us have training in biology, especially neuroscience. There is this field called neurophilosophy, which some people are trying to enter. That they try to study both neuroscience and philosophy, but it's not the major way that philosophy is done. So it's hard for philosophers to talk to neuroscientists. Computer scientists have the same problem. They know a lot about their machines. They have a passing training in philosophy. Maybe you've taken some GE classes, right? You're a computer science major, but you've taken some GE classes in philosophy, maybe also in biology. But that, is that enough, right? Biologists also have their problems. They may know a lot about the biology of the thing that's inside your skull, but they are, in order to be skillful at that, they haven't had time to become skillful at computer science. And also, they just have a superficial knowledge of philosophy. They don't really know what the philosophers are going on about in their arguments. So it's really difficult for these three constituencies to work together. And unfortunately, they have to, right? We're not going to understand consciousness without this and more. There's probably other disciplines. We got to add psychologists in as well. The list could go on, right? We just happened to pick these three, but really almost the entire university at some point enters into whatever your subdiscipline is. You enter into a discussion of conscious life. So this creates this perennial problem. What kind of language are we going to use? How do we translate between all the various disciplines? And this has just become more and more and more severe than it was in the last century. This century is just going to be all about the difficulties of all these disciplines butting heads, trying to make sense of something that we all care so much about, but it will not fall to any one particular discipline. Okay, so that brings us out to the last part of our talk here. So I'm going to do my last poll. So let's stop sharing these results. Let's go to our third question. So this is the question: is artificial intelligence ethical? Is our artificial intelligence ethical? So I'm going to launch that. See what you guys think. All right, in the next two chapters, we talk about ethics in AI, and we do it from two different directions. So the first one is questions about the ethical impacts that AI technology itself has on the world. The last part of the book, which I consider a pretty interesting part of the book, is the question of whether or not we can conceivably construct machines that actually could think about ethical problems the same way or better, hopefully better, than the way that you think about ethical problems. Okay, so let's get into it. AI ethics is what is the debate about, once the people constructing AI decided to just punt on the idea of trying to create an all-encompassing world mind and instead focus on narrow problems, they started having wildly successful applications. So there's millions of AI applications. Many of them you go unnoticed because they're not useful, but a few of them become very useful and they become key cornerstones of your life. For instance, the way that Netflix decides on what movie you should watch next, right? That's all done through AI, and you use it and you like it, and it's been a money-making application. Um, so, uh, unfortunately, when it comes to AI and ethics, AI uh, didn't really spend a lot of time thinking about ethics early on. In its first, 50 years, it left all these questions to science fiction writers, essentially, to worry about the potential impacts of AI, even though they were readily apparent, even from the very first uh, uh, article that launched the field, Turing's article. He even addresses some of the fact that it will have ethical impacts, and then he says, "Oh, but just forget about that, right? Doesn't matter what ethical impacts happen. That's not going to stop AI. Could be good, could be bad. Well, only thing I care about is the machine intelligence itself. What happens, I don't know. But I'm working on making machines intelligent." So I bring up the comments of Stephen Hawking just as an example. There's other technocrats and scientists. There's a whole army of them, really, that share this view. But Stephen Hawking just is a famous fellow who you recognize, and he said in October of 2016 that success in creating effective AI could be the biggest event in the history of our civilization, or the worst. We just don't know. So we cannot know if we will be infinitely helped by AI, ignored by AI, and sidelined, or conceivably destroyed by AI. So for somebody as smart as Stephen Hawking, it's kind of a toss-up. We build this stuff. Is it going to be good for us? Is it going to be neutral? Is it going to be uh, an extinction level event? Right? Who knows? Right? Just roll the dice and see what comes up. And I don't even know what the odds are when I make this roll. Um, okay, that seems really dangerous, right? If I said, open this door, I don't know what's behind it. It could be $1 million. It could be a tiger that will instantly eat you, or it could be a cupcake. Um, would you open that door, right? Knowing that, not knowing even what the odds are, right? Maybe the tiger being there is 99.999% the case, right? You just don't know the odds. How do you make a decision like that? Okay, one of our authors, Eric Dietrich, has an interesting argument that suggests that maybe we should just open that door because um, he thinks that it's logical to believe that we make these machines, they will be able, if they are able to generalize the way an AGI machine would be able to, then um, it would be able to do this really well and much better than we could. So it took us around 200,000 years. Um, sorry, I left out a zero there. Um, I'll fix that later. Um, it wouldn't take us that long, or sorry, it took us that long to figure out that slavery was wrong, right? And we still haven't really fully figured that out. It's not like there's more people in indentured servitude now than there ever was in human history. So we're still having trouble with that. But a machine, all it would have to do is think about slavery for a millisecond, and it would be done with it, right? They would be instantly our moral superiors. So it follows that they wouldn't kill us, right? They would be beneficial. They'd want to take care of us. As a matter of fact, the same way some of us want to take care of environments or animals. Um, they'll do better mathematics. They'll do better science. They'll do better art than we do. They'll do everything better than we do. They will even morally reason better than we do. So because of that, because of the fact that we know we have these problems, we're smart enough to have the idea that slavery is probably wrong, but we're not smart enough to solve that problem. We're smart enough to know that we should be treating each other well, but we're not smart enough to figure out how to actually do that. We're smart enough to know we shouldn't be killing each other. We're not smart enough to actually stop killing each other. So we're just almost there, right? So it's our moral duty to create the entities that would take us the rest of the way, right, and bring us to a world in which that kind of stuff doesn't happen. So we have a moral duty, according to Dietrich, to build these kind of machines, and then after building them, right, we should just exit stage left. get out of their way, because they're going to be better than us. We should just go into retirement, right? We could do a slow extinction, right, or a fast one. Just get out of the way, right? Okay, so moving on, we also have a chapter on the fact that AI ethics is this hot new topic. I'm sure you've read lots of articles about it. I've read 2 or 3 just in the last week. Everybody's talking about it. Um, it's uh, AI is a thing, especially with the advent of deep learning, sophisticated artificial neural networks. Um, we've beaten the Go champion, the chess champions, right? These machines are smart and capable, and they can do a lot for us. Um, Unfortunately, they again work on narrow frames of reference. DeepMind beat the reigning Go champion of the world, right? But it doesn't even know it beat him. It doesn't even care it beat him. It has no capacity to do anything other than play Go or a few other kinds of games. It's a pretty limited machine, even though it's an astounding accomplishment, astounding human accomplishment. So that means that these machines will do their astounding tricks, but they will create wreckage in their path as they do so. They will be phenomenal at the one thing that they do, but incapable of understanding the impacts of that one thing that they do. So that brings us the world, the fabulous world of tech ethics. And this is just, I just grabbed this from the Wikipedia page, just a current list of some of the groups doing high-level AI codes of ethics. This list is completely incomplete. I added a couple more at the bottom. You could add dozens and dozens more. Basically, every single major corporation has its own a little AI code of ethics. So European Commission has one. Obama administration tried to create one. The Trump administration didn't do much with it in its 4 years. Made a couple pronouncements, but never funded those pronouncements. There's a Computing Community Consortium, Center for Security and Emerging Technology, Institute of Ethics and Artificial Intelligence, the IEEE Ethically Aligned Design. That's a group that I'm involved with that produced a really massive book on AI ethics, covering every conceivable impact that was imaginable at the time that we wrote that. And then there's the P7000 ethical standards group, which I'm also a member of, on the AI nudging, which is trying to produce standards for how should machines that try to think ahead of you like they would in a game and nudge you into particular behavior. If a computer is going to beat somebody like Garry Kasparov, it has to nudge Garry Kasparov in chess to make some mistakes, right? That it can capitalize and win the game. Obviously, machines can do that in certain domains. Will they be able to do that? Like when you enter a grocery store, will AI be nudging you through various techniques to buy certain things that you didn't come into the store to buy, but would be profitable for the store if you did buy them? So what will be the ethical standards for building machines like that, which obviously we will build? So this is a huge topic. You can get involved in it. There's the ethics, there's the law, AI law, huge thing. I know a lot of people in the class are interested in law. You can do your entire career on that topic alone. It's big, big stuff. Okay, AI is dead. Long live the AI application. So we don't care. Nobody seems to care much about building artificial general intelligence machines. Maybe Elon Musk does, but a few people, and he doesn't even really spend much money to actually do it. So nobody's really putting their money where their mouth is with that. But where they are putting their money is in AI applications. And some of these applications are problematic. For instance, quite a lot of money was made in the AI industry during the initially during the Bush administration, and then continuing through the next 2 administrations, making money off of automating warfare, making machines that can do the jobs that soldiers usually do, put soldiers in danger. So so there's that, right? And we've had a whole list of people signing petitions against that kind of technology. There's all kinds of problems that are that we can think about here. Um, Autonomous weapons, autonomous cars, AI recommending systems, medical applications. The list is massive, and these are real people, right, are living and dying based on the programs written by AI engineers. And this means that we have to take a really deep look at this industry and find out what's going on here. What are the systematic biases that are being written into code that make these things impact our lives in negative ways? Okay, the last part, won't have much time to talk about this. I gave a lecture 2 weeks ago in the computer science department on this particular topic, so you can take a look at that recording there if you want to get into the weeds on this. But um, basically, this is just the last part of our book where we talk about, can embodied AIs be ethical agents? Um, and the argument here is that now that we care about consciousness again, we have to pay some really close attention to the fact that ethical decisions tend to be conscious decisions, tend to be decisions you make consciously, weighing options, understanding consequences, understanding who the characters are that you're talking about when you're making an ethical decision. Can machines do this, right? We've already realized that our AI has become really problematic. It doesn't seem to be able to on its own make ethical decisions. Unethical actors are using the technology to do unethical things. Maybe we can be saved by, the science fiction writers. Remember, I said that the science fiction writers were the ones that were paying attention to this many decades, 70 years ago or more. They were paying attention to this, and so maybe we can look to them. Unfortunately, if you've seen movies like I, Robot, you'll understand that some of the way, especially Asimov's solution to the AI ethics problem, fraught with difficulty. These laws contradict each other. A machine that was programmed with them would make continual mistakes, and they always do in all the movies. All the movies wind up with these machines making huge ethical blunders. Okay, so that brings us to, well, it looks like we're going to have to get creative and rethink this problem from the ground up. So the argument that we come up with in the book, we've got more details, like I said, give you those details in other venues. But the idea is that we need to create interdisciplinary pathways where we can connect cognitive science, philosophy, computer science, neurology, psychology, all of this stuff together to create teams that can design better, more ethical machines. I'm not making a commitment, none of us are, that this is actually possible, unfortunately. But I do, in this chapter, point to directions where it's conceivable we might have some success. Currently, nobody's working on these issues, but we argue that they ought to, and that it's going to be important that our machines be able to make ethical decisions, because we already know that unethical actors already use the machines to do unethical things. Okay, so that takes us to the end of the prepared talk. This is the book itself. You can get the paperback for $40. Hardcover is pretty expensive. I don't recommend that necessarily. Paperback's affordable. And if you are a SSU student, please consider taking my winter session class. We'll get into these details, each one of these details, in the second half of the book, the AI ethics part of the book. We will get into in Philosophy 302 this winter. It's a great class. People have a wonderful time, and it's fully online, asynchronous. Great class. Been running it for a number of years. And then there's Philosophy 309, Robot Ethics, which is open right now for the spring, in which we will go into this book in great detail. I'm going to be using it as the textbook. Okay, so I think we had, I'm going to stop sharing the screen here. I think I had a hand raised from Kim. Um, see if I can find you. Here you are. All right, Kim, I opened up your
Hi,
talkability.
Tom.
Hey, can I
So
be sure this is actually Kim, or is this Kim's robot?
no, it's actually Kim Hester Williams, and I have been delighted. I have really enjoyed the Cells lecture series. This is my first time really going all in, listening to many of the lectures,
Mhm.
and particularly these last two, because the last one was also about artificial intelligence, or the limits of
Yeah,
robotics and computers in our daily lives, and how they can be used for good or not. And I loved, yeah, as you know, I teach iRobot, the novel and the film adaptation, every single semester. Students are fascinated by it. As you know, both the novel is and the film are very popular, hugely popular, and I think it might inform the way people think about artificial intelligence.
absolutely.
So yeah, so I was wondering, and the students love it. We just endlessly debate whether the premise of iRobot, whether it, and the three laws,
Mhm.
whether they are you know, feasible, whether they're just imaginative, whether they're flawed. And so for you to say, I was really appreciated hearing you. I was waiting all the whole for you to talk about this. Um, you said it's problematic because of course the robots will constantly make mistakes if they follow laws that are contradictory. And as a English professor, I think that's the drama. The drama in the novel is that they
Right.
that it's contradictory.
Yeah.
But I'm wondering if you think that it has any validity, if Asimov in the novel was trying to critique the notion of artificial intelligence. What do you think he was trying to do in that novel?
Yeah, it's interesting. I think probably he has a very long career, and I'm sure his ideas evolved over time. But there's clearly instances during interviews where he's specifically offering the three laws as a solution. So there is a portion of Asimov's mind where he thinks this really is a good answer, and in his books he's trying to rethink these. This is why there's not really just three laws. There's actually four, right? He adds the zeroth law later in his works as an attempt to try to plug some holes that his earlier works had laid bare. So I think he meant it for real. He was a big fan of artificial intelligence and a huge booster of it his entire life. So I do think he is really excited about artificial intelligence, but also was smart enough to see the great ethical impacts that this kind of technology will have, especially when we start putting robots everywhere in our actual lives. Um, so I think it's important to pay attention to his works and read them, especially in the context that you're reading them in. Only thing I'm arguing against is sometimes I go to events with AI engineers, and I have heard AI engineers say this, like, "Oh, we solved that problem, right? The three laws, they are like it's done, right? What the hell are you here to? How can you possibly add to what's already been done?" And that's where I think that this is problematic because the laws are they were invented by an author, right? An author who wanted to create drama and interest in his stories, and and that's where it becomes interesting, is that the machines make these mistakes, and it's the humans around them that have to try to provide the unexplicit ethical expertise to disentangle these particular situations that happen. So humans are always really important in the stories to untangle the problems that the machines get us into in their lockstep, unthinking adherence to rule-based behavior.
Thank you.
Mm-hmm. All right, so that takes us up to the top of the hour, and I'm going to let everybody go that needs to be at other things. Thank you so much for coming, and we had a really great series this year. We got another one in the works for next fall. So hope to see a lot of you there here next time. So thanks a lot for being with us, and I will look forward to working with you in the future. I'm going to keep the line open, answer a few more questions for people that stick around like we normally do. But for those of you who need to go on to other things, I bid you adieu. Thank you very much. All right, let me take a look at a couple of the questions here and see if there's a couple people still left on the line. So I see a question from Nils. You say iRobot is problematic due to robotic mistakes. Humans make mistakes too. Right, humans make mistakes too, but they don't, and they can make robotic mistakes. And I think this is a really interesting piece of roboethics as we attempt to make ethics more and more palatable to machines. We are also going to be creating humans who are more and more rule followers rather than frenetic thinkers. Phronesis being a word we use in philosophy to talk about skilled moral reasoning that goes beyond the rules. So you're right. I think that as we move forward, we might be making less and less humans that are capable of making skilled moral reasoning. And it doesn't, in that kind of a world, it doesn't even matter if we create artificially intelligent machines, general intelligent machines. We might be reducing our own capacities to the point where we can't make these kinds of skilled decisions anymore. And in which case, yeah, that sounds like a dystopia of some sort. Let's try not to go there. Okay, why do we have to moral duty to build these machines? So this was from Madison. The argument being that we're terrible at moral reasoning. So this would be the opposite. This would be the idea that machines, through the three laws or whatever, right, whatever programming scheme we come up with, our programming scheme that they come up with. Remember, artificial intelligent machines can reprogram themselves. So maybe, we're having trouble. We can't come up with anything that isn't obviously contradictory, but maybe the machines themselves could. So at that point, if they were capable of doing that, then their decisions would be more moral than our decisions, and therefore we have a moral duty to create the kind of tools we need in order to solve the really difficult moral problems that we encounter. Now, we've got the kind of brain that was evolved to solve small tribal questions, right? Moral questions in small tribes of humans and small families. We don't live that way anymore. We live with billions of people on the planet, all interacting, and the things that they do infect, literally in the case of COVID, they literally infect us, right? So things that somebody does on the other side of the world eventually comes and affects your life as well. So this makes every little decision you make, it might have a butterfly effect, right? It might cause a big thing, or it might not, and it's really hard for us to know these decisions. Is the fact that you decide to buy a plastic bottle and throw it away, is that going to be the one thing that tips the world into unbelievable ruin, environmental ruin, or not, right? Probably not, but it might be, right? So how do you make these decisions? Dietrich's argument is you can't. You need the apparatus of very intelligent machines helping you make these decisions so that you don't, by mistake, create a catastrophe that destroys the world. So that's why it would be our moral duty to create a machine like that. All right, let's see, we've got a couple more people here. Jordan asks, even with the most ethical machines and advanced security, do you think that most people would be okay with it or more nervous? That's a great question. It seems like from our polls today that people would be, oh, did I ever look at the last poll? Let's take a look at the last poll. I didn't. Here's the results of the last poll. So Are AI ethical? Only 7% think that yes, they are completely ethical. Only 4% think they're completely unethical. The majority, 68%, said yes, but there are some small problems. So they're leaning to they sort of not completely buying Dietrich's argument, but they're amenable to it. That there are some small problems. Fix those small problems, and then AI will be uh, more ethical than we are. And then 21% said no, but there is hope that one day they might. So pretty hopeful audience that we have here, um, as far as whether or not machines could be ethical. Um, all right, let's take a look at a question here from Ryan. Is it possible to design some AI to override unethical commands from an unethical person using the AI? Yeah, this is the key question, right? This is the most important question. I'm glad you asked that, Ryan, because right now the machine will just do what it's programmed to do. So if you want to program your autonomous car to run over pedestrians, instead of avoid them, you just flip the bits and say, instead of turn left, turn right into the crowd, then it'll do that, right? With no problem at all. It's just following its commands. Um, so we need to have machines that will disobey unethical orders. Um, Now, this is a really tough question because this means that we're going to build machines that are necessarily beyond human control in some instances. This itself can be a little bit worrying. Do you really want a machine that can do what it wants to do and not what you want it to do? Um, it'd be like your pets, right? Your pets, uh, you don't want them to eat the whole bag of pet food, but if you leave and the bag of pet food is available to the animals, they will eat the whole bag, right? They have their own wants, needs, and desires. So do we want to give AI its own wants, needs, and desires? And and that would be necessary in order to make this a possibility. I've worked with roboticist Ron Arkin at Georgia Tech, and he was working with the U.S. government, and he has a really interesting uh, proposal. He proposed that yes, we want to make some of these lethal autonomous weapons that we're building capable of disobeying orders that are immoral. So think about this. Think back in the Vietnam War, the Malay massacre, where many U.S. soldiers just obeyed their orders and were killing civilians. But there were a number of U.S. soldiers who stopped. Like there was a helicopter pilot who just landed his helicopter, ran out, and stood in front of the people that were being machine gunned, and said, look, you're going to have to kill me if you want to kill these people as well. So there are these moral heroes, right? That we know that some human soldiers are moral heroes. Some human soldiers are moral monsters. We want to make sure that our machines don't just become moral monsters, just follow any order. They'll kill anything you tell them to kill. And so he put into his program sketch this thing he called an ethical governor, which was a variable that would ratchet up as it received more and more questionable orders from a particular source. It might pass a threshold in which it says, "Look, I'm not taking any more orders from you. We're gonna send this up the chain of command because I'm pretty sure that what you're asking me to do is violates laws and ethical norms and our rules of engagement that we have operating here in this particular combat mission that I am, a drone being used in." So that seemed like a really interesting idea, but the military shot that down literally right away. They did not want to conceive of building a machine that had the capacity to disobey an order ever, right? So it's an interesting argument that I think we're still trying to work our way through. Okay, let's see. Answered that one. Let's look at any other questions here. Here's a couple. Vince asks, do you think robots will see cyborgs as one of them, are one of humans, or neither? Okay, so yeah, we didn't really, in this lecture, and really in this book, not until the very last chapter do we start entertaining this concept of the cyborg. So the cyborg is a machine-human mix. Arguably, some philosophers like Andy Clark argue that we just already are cyborgs. Can you possibly leave your house without your phone, without without feeling intense actual pain? Right? If that's true, then you are a cyborg, right? Already. So you're already kind of a mix of AI and human biology already. Many of us are. I'd count myself as one of those people as well. So will a pure machine accept a cyborg as an equal, right? Yeah, that's a super fascinating question. I'd say, you know, write a book. That sounds like a good science fiction novel question to answer. I don't know. I don't know until we see it. Some people argue that we're not going to get this AI, this general intelligent AI, in a pure machine. That it's going to have some aspect of cyborgness to it in order to get to that level. So it might be that the kind of machines that we're worried about right now just are the cyborgs. So you know, that could be, in that case, the question would be whether they would accept a pure AI machine. So I don't know how to answer that, but I do think it's a fascinating question. I'd love to see some novels and books that explore that question. And as we get more and more closer to that world, then we'll be able to answer that question more scientifically, more philosophically. Heidi asks, will these robots have a high risk of making mistakes just as a human would? How efficient would the help be when compared to a human? Okay, so that's an interesting question. It depends on the domain, right? Your calculator is probably not going to make an error in arithmetic the same way that you would. So in some domains, machines are very unlikely to make an error. The only thing that they can make errors, there's things like they have this interesting problem that humans don't seem to have, which is called bit flipping, and a perfectly good program running on a perfectly good machine might be hit by a cosmic ray just in the right spot to flip a magnetic bit on its program, and that can have consequences for the program. It already has had consequences for programs. It had consequences in the Toyota case where the car had it wasn't an autonomous car, but it was a car that had the ability to accelerate on its own and keep its own acceleration moderated, right? Cosmic ray hits this machine in just the right way, and the thing goes into an uncontrollable acceleration. So yeah, that wasn't the fault of the programmers, and it wasn't the fault of the machine. It was just an accident of nature, right? So all these machines will definitely be subject to that, of course, just like anything that's in the universe is subject to accidents. But in limited domains, right? As long as we keep our frame really tight, and we're talking about a solvable, computable problem, then machines will do those kind of problems better than humans will. Okay, Roger. Hey, Roger, good to see you. Roger asks, when the AI machine achieves its own consciousness, will society be able to grant it equal status as humans? Yeah, it's up to us. And that, I do find that really interesting. One of my colleagues who we address this in the book in relation to the arguments that are coming out in terms of robot rights. There quite fascinating. So there's a way to look at robot rights as sort of an example of uh, we as humans have been extending rights more and more broadly uh, over the last few thousand years. So there was a time in which the only human that had any rights would have been the supreme ruler. And then we started expanding from there, right? More and more uh, 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 actual legal rights, right? That you could get upheld in a court of law. So aristocrats started getting rights, and then that gets codified in something like the Magna Carta, right? Very strongly, right? That they have these rights, and then these rights extend out from there to the lower and lower social levels, to the point where now we grant rights to all humans, right, regardless of their race, class, or gender. We're even now talking about extending rights to animals, right? That's not a joke. That's a serious topic of concern amongst philosophers, has been for a number of decades. We might extend, we certainly do, right? To your pet dog has a certain number of rights. You can't just murder that thing anytime you want to. You'll pay some consequences for that. Um, so we have extended rights to certain animals. Um, we may get to the point where we extend them to all animals. Uh, we may get to the point where we extend rights to ecosystems, right? So yeah, we as a species, we've been engaged in this really wonderful expansion, rapid expansion of the things that we consider have moral rights. So will we extend those to machines? I think so. I have a number of different articles where I write about what I think would be the minimum requirements for machines. But now you'll have to remember, I believe very strongly that environments have certain rights that we have to recognize. So my level for what kind of machines have the status of like an environment, right? In which case it would have rights, or a very they're low, right? So you may be uncomfortable with the level where I'm comfortable at granting certain kinds of rights to machines, not because I think they're human level, right? It's just that I think that they're equivalent to certain biological. They have the same status as certain biological creatures, which I also think have certain rights. Now, these rights are not uh, uh, inviolable, right? They are defeasible, of course. Um, I would rather you save me than my laptop if we're in a burning room, right? So there's complexity there. I don't want to just say that it's this binary thing. All rights are no rights. I see it as a grayscale where you can have certain rights and not others, certain responsibilities and not others. So I think that we should already be there in the way we think about machines. Okay. Um, so will others follow me? I don't know, Roger. I know you would, um, but I don't know if anybody else is up to this. Like um, we have a hard time saying Black Lives Matter, right? If we can't say that, right, how are we going to say, robot consciousness matters? Right? We're not going to get there. So we've got a lot of work to do as a species before we get there. But I don't think it's impossible. I think we will get there. All right. Let's see. Did I answer this one? No, I didn't. Cole. If computers seem to think and learn through patterns and numbers instead of logic and emotion, would it be logical to say that any thought or idea that can be converted into a mathematical equation would be learned? Yes, absolutely. That's computational thesis, right? So whatever it is possible for math and computer science to do, then those machines can do it, right? That's just a truism. Um, Now, where this question gets interesting is when you're thinking about what could a future machine do, right? So we know what the machines we have right in our pockets today can do, but the question is, what can the machines 20 years from now be able to do? They'll be able to do. The argument is they'll be able to do more. This is an expanding field, not a contracting field. So at that point, what will machines be capable of doing? So that's why I think our machine's capable of making ethical choices. I just consider it an empirical question. We just have to build the systems and give it a try and see what happens. I think that I don't try to, my money. I guess I would bet a little bit of money on the fact that they could. I think that would be worth investing in because the reward of a successful machine would be very high. But would I put all my money into it? No, absolutely not. Right. So, I have degrees of faith in that stuff, and I don't have total faith that will happen, but I do have some faith that it could happen. It could happen. Okay, Aaliyah asks if artificial intelligence is not ethical, and it's not right at this moment. Absolutely not. It doesn't have the capacity to make these decisions. We haven't even really spent much time trying to make it capable of making these decisions. What are the steps we can take to make sure that we can get to a point where it is, since it is inevitable, we will have AI? Right. Great question, Aaliyah. This is the key question, I think, of your generation. One of them anyway, and that is we have to start taking the steps right now. So unfortunately, like I see a huge interest within the industry. I showed you that slide with dozens and dozens of high power groups that are well funded, trying to come up with ways to make AI more ethical. Unfortunately, so much of this just seems to be ethics washing. But when you really dig into these codes, there's not much to them. There's not much. They can't really be enforced. Basically, you know, a company can say, look, we consider it we do not want to create unethical AI machines. Yet they still create a machine that pries into your privacy in order to sell you useless garbage that you don't need. Right? They will still do that, even though they've got guaranteed they've got a statement that says we will never create unethical AI. So you can say all the platitudes you want, whether it changes your behavior or not. This is what's really important. And I don't think none of that behavior is going to change until we actually create standards, right? Standards that if you want to sell this product in this particular country, you have to meet these minimum standards for privacy, let's say, right? It's only when we get there that we're going to see some movement in the right direction with this. And that's what I try to get into, trying to create the kind of people that will create that world with the classes that I teach here at Sonoma State. So hopefully we will get a bunch of people that are involved in making this happen in real technology companies. Oh, it looks like he's gone, unfortunately, but one of my mentors early on in this world was Dr. Scott Noam Cook, and he got me a job up at Xerox Palo Alto Research Laboratory, where we worked on trying to take some steps forward in the problem of creating ethical technologies at big technology companies like Xerox. A hard problem. People have been working on it. I'm happy to say that there is more of that activity now than there was in the 90s when he and I were pretty much the only philosophers resident in the corporation. You'll find, a handful of philosophers in many corporations now. And that's a good sign, right? But there's still much work to be done, and I'm here to try to help advance that idea. All right, got enough time, 5 more minutes. What does it take for an AI or any technology to be conscious? Wow. Uh, if we could answer that question, you know, you and I would receive a Nobel Prize. We know consciousness is this weird, really interesting phenomenon. We use the word consciousness. There is some worry that we're using this word the same way we might have used the word ether a couple hundred years ago. Intelligent people use the word ether as if it was something that actually existed. And it's possible that we're just deluded and we use the word consciousness as if it was something that actually existed when it doesn't. I feel my money is that it is something that's real, but it is unlikely that we fully understand what it is that we're talking about. If we did fully understand what it is we were talking about, we would be able to model it better, explain it better. You could take Consciousness 101 at Sonoma State and have a textbook that explained it to you. We have nothing like that right now. So it is a very interesting field that is still very murky, and we don't have mathematical models. We don't have well, we do have mathematical models, but we don't have widely accepted mathematical models. We don't have widely accepted ways of measuring consciousness, like how conscious are you right now? Does it I'm sure it definitely has something to do with alpha and beta waves that are going on in your brain, but it's not entirely that. So when we talk to neurologists and the people that ought to know, they don't really have a great explanation of what consciousness is. So this is this massive open question, and it's such an interesting one because it's, like I said, it's where we all live, right? The most important moments in your life are conscious moments in your life, and therefore consciousness, I think, is the most important thing to us, and it's the thing that we know probably the least about scientifically. So we know it's not like that we're completely in the dark, but we are definitely have only taken a few tentative steps, and it's hard to know if we've taken those steps in the right direction or not. But if you get into consciousness studies, you're going to learn different ideas. There's 4 or 5 different ways that people have proposed as ways to measure consciousness. Like, wouldn't it be great if a doctor could just put the conscious meter onto a patient who is in a vegetative state and say, yes, this patient is still here, right? There's still a conscious brain in here, or no, and we know there's no chance of it ever coming back, right? That would be very useful information that a family would like to know. But unfortunately, we only sort of guess at this. It's kind of frightening when you think about it. We only just sort of guess at this. We have some brute force ways of altering our consciousness, right, through drugs that aren't very healthy, and through anesthetics, which have different kinds of side effects. We do seem to be able to turn off consciousness and turn it back on in order to do surgery. That's a nice thing, but why it works and how it works and all of that we know very little about. So sorry for the roundabout answer, but that is sort of where we're at as a species with that. So I do not know what it will take to build an AI consciousness. No one. Here's the answer that we come up in the book. No one knows the answer to that question. There are a few theories, but they are hypotheses. They're not even theories. They're just hypotheses of what consciousness might be about, and the direction in which we could take machines. One of the authors in the book believes that we probably will stumble upon AI consciousness, but completely stumble upon it. Like, we will have been building these machines and we won't know why or what we did, but we wound up with a machine that's conscious. That's sort of how nature did it, right? So it's conceivable that we could stumble into it as well, depending on how likely consciousness is in the universe. Is it highly likely? Is it unlikely? One of the one of the theories that's out there, panpsychism, is this idea that everything is conscious, like everything has at least a little bit of consciousness, and then it's like mass, right? The more you stuff together, the more consciousness gets displayed. So every single atom in the universe would have a tiny little bit of consciousness. And then when you take a creature like us, where we've got a whole trillions and trillions of atoms all stuffed together, right? That consciousness accretes to the point where you can get consciousness out of it. Okay, that makes a certain amount of sense, but then you'd have to ask, why then isn't a mountain conscious? Because it's got a lot more atoms in it than I do. And how come it doesn't have the consciousness in the same way that I do, or the whole planet, right, or the whole universe itself, right? So there's something still strange and unanswered in that particular theory. But that's just one of the theories that's out there. There, like I said, there's 5 or 6. They're all equally good and equally terrible, and none of them has risen to the point where they're accepted, to the point where we would have a consciousness department and consciousness 101 as a class in a university. Okay, so that takes us up to 1:30, and we have a great session here. Thank everybody for attending, and looking forward to hearing your comments. You can send me an email. I'll answer some comments later, and I'll try to address some of these other questions for my class, for the people that asked questions in the class. All right, so thanks a lot. Not the last word that we'll ever say about this, but looking forward to talking with you in other events in the future, next spring and next fall. All right, see you all next time.